Alright, so I just wanted to make this little video here, talk about sets, inequalities, and interval notation. So use a couple different, want to introduce a couple different notations here. So the one is the set builder notation. Basically the idea is we have some set S, we take elements from some given set which we know, maybe the real numbers, and then we place some condition on X, and this is what we mean by set builder notation. Here, this funny looking E it means element of. So to say X is XER like this, what that means is that X is an element of the real numbers. Here's a silly example. You could say S is the set such that X is from the set of all movies and X is not a Marvel movie. So, for example, Fast and Furious, would that be an element of S? Well, some people would argue yes. I made arguments that perhaps we should think of Fast and Furious as a Marvel movie the other day. But anyway, silliness aside, here's our intervals right here. So there are a number of basic kinds of intervals, and for each one of those we can either look at it in terms of so-called interval notation, or the set builder notation where we say X and then the condition on X, right? Interval, set builder, interval, set builder, interval, set builder. Sometimes set builder is also called roster notation, especially when it's just got a finite number of things in it, like this last one is the set containing just one element, the so-called singleton. That's the oddball here. The other ones I have so-called interval notation for. This is infinity, so like A to infinity, or A included to infinity, minus infinity to A not included, minus infinity to A included, A not included to B included, A included to B not included. All of these are examples of intervals. Intervals are what are called connected subsets of real numbers. If you like, we can visualize them on the number line. Every interval we can draw, we can visualize by using our marker, right? And we can draw it without lifting the marker. In each case, an interval is connected in this sense, all right? So these are the number line presentations of the sets, the interval notation, the roster or set builder notation, and there's these, so we have these three different ways of looking at it. Of course, there's also the whole real line. It's an interval, minus infinity to infinity. So with that notation down, let's look at some examples. I've got a number of examples to share with you. Let me grab a sheet of paper here so I can cover up some of my examples. All right. Sorry I couldn't be with you guys in class today. I'll try to keep this shorter so you have time to work on some homework once you're done with my video here. And of course, if you're stuck on something, you can email me. I am checking email right now. I couldn't be in class today. I'm sorry about that. So these are the basic things we can do with inequalities. If we have an expression 1 is less than or equal to expression 2, then whoa, it's really bright. We can add the same thing on both sides, right? And goodness gracious, it's burning into my retina. I better use something else. So I'm just trying to say, like, down here I've got A less than or equal to B implies is equivalent to A plus C less than or equal to B plus C. But in practice, A and B are usually like some sort of expression involving X and numbers and stuff, you know? So I hope you understand that 1, 2, and 3 are patterns that we follow, right? And you can think of A and B as shorthands for expressions. And C, though, I typically, well, C could also, in this case, C could be an expression like something involving X, but usually when I multiply by C, I try to stick with just pure numbers, either positive or negative. We don't multiply by 0. All right, so those are the what's the word here? Those are the allowed moves in the game we're about to play, right? And so let's look at them. Go ahead and shift this up a little bit. Try to make sure I'm not out of screen. There we go. Alright, so, oops, looks like I need another cover sheet here. Alright, so to start with, if we have x plus 10 is greater than 2, how do we solve this? I say find the solution set. So each one of these examples, I've put the problem in green and the solution in red. Alright? So, alright, so to solve this, what we do is we subtract 10 from both sides, which is just like adding a negative number. That's, you know, in number 1, if we add a negative number, it's like subtraction, right? So subtract 10 from both sides. 10's cancel on the left-hand side, and 2 minus 10 is minus 8, so we get x is greater than minus 8. So you could even box that, right? That's one presentation of the solution, but if you're asked to give the solution in interval notation, you should do this. X is greater than minus 8, so that goes from minus 8 to infinity, just like that. Alright, since there aren't any questions, I'm going to move on to the next one. It's funny how questions don't slow me down today. Alright, is x equals to 3 a solution to 2x minus 4 less than 11? So how do you check if something's a solution to an inequality? Same as we do for inequality. We plug it in and see if it works. So plug in x equal to 3. We get 2 times 3 minus 4, which is 6 minus 4, which is 2. Is 2 less than 11? Yes, it is. So yes, x equals 3 solves 2x minus 4 less than 11. Let's look at the next one. Alright, find all solutions to 2x minus 4 less than 11. Alright, and present your answer in interval notation. So I'll start with 2x minus 4 less than 11. My next move is to add 4 to both sides. That brings me to 2x less than 15. Then my next move is to divide the inequality by 2. Since 2 is positive, it doesn't change the order of the inequality. So I get x is less than 15 over 2. That's one way you could write the solution, but I asked for the solution in interval notation. So we say, okay, that means that the solution is minus infinity to 15 over 2. In other words, x is an element of that interval. That's the solution. Now, I don't make you write x is a funny e of that. In practice in this course, you can just give me the interval and I'll be happy with that. All right, let's look at example 4. All right, and cover up this other jibber jabber. So here's problem 4. Solve 8x greater than 40, greater than or equal to 40, and plot the answer on a number line. 8x greater than or equal to 40 is equivalent to the same fraction, same inequality divided by 8. Of course, 8x divided by 8 is x. 40 divided by 8 is 5. So this 8x greater than or equal to 40 is the same inequality as x greater than or equal to 5. And on the number line, we include 5 and we just keep on going. Like if I was to plot x, it'd be something like, it could be here, right? It could be anywhere in there. That's the point. That's what that picture means. Example 5. So example 5, I'm supposed to solve 3x plus 13 less than or equal to minus 4x plus 20. Alright, so my first move is to add 4x. Adding 4x cancels that 4x and brings 3x to 7x. So 3 plus 4 is 7. 7x plus 13 less than or equal to 20. My next move is to subtract 13. That gets rid of that 13, leaves us with 7x less than 20 minus 13, which is 7. So then we have 7x less than or equal to 7. So I can divide this inequality by 7, which is positive. It doesn't change the less than or equal to anything else, so it's just less than or equal again. X less than or equal to 1. So in interval notation, we have minus infinity to 1 as the answer. So the homework that you've been assigned, it involves both the interval notation, the number lines, and the set builder. It's all in there. All right. Let's go on to our next examples. So here we go. Solve. Make sure I'm still in frame. Alright, I think we're good. Minus 5x less than minus 100. Solve this. Alright, so notice that this time we have to divide by minus 5 to get from here to here. Right, so dividing by minus 5, notice it reverses the inequality from less than or equal to greater than or equal to. And so we get x greater than or equal to minus 100 over minus 5, which is 20. Right? You know, just again, a short reminder, why does that happen? Well, if we had, let's look at it, if we had 3 is less than 5, that's true, right? If we multiply by minus 1, what happens? That's minus 3, right? Fill in the blank. And minus 1 times 5 is what? Minus 5. Is minus 3 greater than or less than 5? Well, minus 3 is greater than 5. You can see by this simple example that when we multiply by a negative number, we have to flip the inequality. Alright, so we have x greater than or equal to 20, which in interval notation gives me 20 to infinity. Alright, next up, example 7. Much the same. Minus 3x greater than 10. Solve it. So we divide by minus 3. When we do that, that flips the greater than to less than. So we've got x less than minus 10/3, which in interval notation gives me solution minus infinity all the way out to minus 10/3, not included this time. Notice the last time we had greater than or equal to, which made me include the 20, whereas this time we have less than, a strict inequality, which means we did not include the minus 10/3. Watch out for that. It'll make your answer wrong if you're not careful. So that brings us to example 8, right? Example 8 here. We have 3 times parentheses 5x minus 6 close parentheses greater than or equal to 8 times parentheses 2x plus 3 close parentheses. Solve. Alright, so here we really need to do some algebra before we try to solve the inequality, so I'll just go ahead and do that. 3 times 5x minus 6 parentheses, parentheses 5x minus 6 close parentheses is 15x minus 18 distributing, and 8 times 2x plus 3 is 16x plus 24, right? So really the given inequality is better written as 15x minus 18 greater than or equal to 16x plus 24. And now we know what to do, right? Because we can add, well, we can subtract 15x from both sides, which brings us to minus 18 greater than or equal to x plus 24. And then we can subtract 24 from both sides to get minus 18 minus 24 greater than or equal to x. Minus 18 minus 34 is minus 42. Minus 42 greater than or equal to x is the solution, or in interval notation, we go from minus infinity all the way up to 42. Uh-oh, there's a mistake in my solution right here. Notice that's greater than or equal to, which means we should include the 42, right? Watch out for that. Alright, moving on. Example 9. Example 9, suppose minus 10 less than or equal to x plus 6 less than or equal to 3. We want to fill in these blanks in the set builder notation to express the solution set to this inequality. There's not much to do here. To make this of the form x in the middle, all we really have to do is subtract 6 from both sides. 6 across that, right? So subtracting 6, we have, let me move this down a bit. Subtracting 6, we have 10 minus 6 is less than or equal to x minus 6 plus 6, which is just x, and less than or equal to 3 minus 6. In other words, minus 16 less than or equal to x, less than or equal to minus 3. So you can see that, in fact, what should go up in here, right, is minus 16 and minus 3, right? So there we go. that brings us to example 10. Example 10 says solve 18 greater than or equal to minus 18 greater than minus 2x greater than or equal to minus 10. Fill in the set builder notation again. So this time we're going to divide that inequality by minus 2. But remember, when we divide by a negative or multiply by a negative, we have to reverse the inequalities. So we get minus 18 over 2 less than minus 2x over minus 2 less than or equal to minus 10 over minus 2, which gives us minus 9 less than x less than or equal to 5. So there you go in set builder notation, x such that minus 9 less than x less than or equal to 5 is our solution. In other words, we can fill in the blanks up here, minus 9 and 5, right? Okay. Moving on here, since there's still no questions, go figure. We have to solve 13 less than 4y plus 11 less than or equal to 29. So look at that. We've got 13 minus 11 less than 4y plus 11 minus 11 less than or equal to 29 minus 11. In other words, I subtracted 11 across the inequality, which leads me to 2 less than 4y less than or equal to 18. But then to get y in the middle like I'd like, I just divide by 4. Notice 4 is positive, so it doesn't change the order of the inequalities. I just get 2/4 less than or equal to y less than or equal to 18 over 4, which is also known as 1/2 less than y less than or equal to 9/2. So we could write it like that in set builder notation, or in interval notation, we've got 1/2 to 9/2 included, whereas 1/2 is excluded, the 9/2 is included. Notice that I have an error right here, right, because it's less than or equal to. All right, the end is near, the end is nigh. Here we go. Last problem. Solve 6 greater than minus 3x plus 4, or 10 less than or equal to minus 3x plus 2. In other words, x is in the solution set if it solves this or that. All right, so we have 2 to solve at once in this case. The first one, 6 greater than or equal to minus 3x plus 4, gives me, subtracting 4 from both sides, 2 greater than minus 3x. But then, dividing by minus 3 reverses the inequality to get me minus 2/3 less than x. And likewise, this one, I subtract 2 from both sides to get 8 less than or equal to minus 3x. Then I divide by minus 3, it reverses the inequality, gets me minus 8/3 greater than or equal to x. So what's my solution? It's x such that x is less than or equal to minus 8/3, or x is greater than minus 2/3. This is not an interval, it's actually two intervals put together, right? The one is the ray that starts at minus 8/3 and goes to minus infinity. The other is the ray which doesn't include minus 2/3, but it goes to infinity that way. And so you can put these together using something called the union. So the answer we could look at is the union of minus infinity to minus 8/3 with minus 2/3 to infinity. This is the answer. I don't think your homework actually asks you to use union in your answer, but it's good to know about because, well, union is one of those basic set operations that you'll need to know about again when you take pre-calculus. So anyway, I hope this helps you, and hopefully we'll meet again in the middle of the week. So thank you.